Water is the most crucial compound for life on Earth, and having drinkable water is a key worldwide concern for the 21st century. All living things require clean, uncontaminated water as a basic requirement. Water covers more than 71% of the Earth's surface, but only around 1% of it is drinkable according to international standards due to various contaminations. Water treatment is a process that improves the quality of water to make it appropriate for a specific end use. The end use may be drinking, industrial water supply, irrigation, river flow maintenance, water recreation, or many other uses, including being safely returned to the environment. Water treatment removes contaminants and undesirable components or reduces their concentration so that the water becomes fit for its desired end use. The source water for a municipal surface water treatment plant is typically a local river, lake, or reservoir. There must be a method to get this water to the water treatment plant. Quite often, a series of pumps and pipelines transport the water to the treatment plant. If you think about surface water sources like lakes, rivers, and reservoirs, you realize they contain varying amounts of suspended and dissolved materials. This material may include turbidity, color, taste, odor, microorganisms, fish, plants, trees, trash, and etc. The material may be organic or inorganic, suspended or dissolved, inert or biologically active, and vary in size from cradle to a tree trunk. Some of these larger items can impact equipment in the treatment process, such as a tree limb getting stuck in a water pump impeller. So, the first process in conventional water treatment is to screen or strain out the larger items. Aeration removes odor and taste to volatile gases like hydrogen sulfate and due to algae and related organisms. Aeration also oxidizes iron and manganese, increases dissolved oxygen content in water, removes carbon dioxide, and reduces corrosion and methane and other flammable gases. A rapid mix unit is usually used where the coagulant is added to the water to provide a very quick and thorough mixing. The example of coagulants are aluminum sulfate, ferrous, and lime. The water mixing is then slowed to allow the water to come in contact with the forming floc and allow it to increase in size. The continued mixing must be gentle to allow the floc to grow and gain weight, but fast enough to keep it in suspension until you are ready for it to settle in the clarifiers. The process of adding a chemical to cause the suspended material to clump into larger particles is called flocculation or coagulation. Once the flocculation process is complete, the water then passes over the weir in the flocculator and travels to the center of the clarifier or sedimentation basins. Here, the water makes its way from the center of the clarifier to the sawtooth weir at the perimeter of the unit. As the water makes its way towards the weir, the large floc particles are allowed to settle out to the bottom of the clarifier. A rake continuously travels across the bottom of the clarifier and scrapes the settled floc to the center of the unit. Pumps are used to pull the settled sludge out of the clarifier and send it to a sedimentation or disposal pond. The water that passes over the weir is collected and transferred to the filters. Clarified waters enters the filters from the top. Gravity pulls the water down through the filters, where it is collected in a drain system at the bottom of the unit. There are many different types of materials or media used in filters, the most common being sand and gravel. Water fluoridation is the controlled adjustment of fluoride to a public water supply solely to reduce tooth decay. Fluoridated water contains fluoride at a level that is effective for preventing cavities. This can occur naturally or by adding fluoride. Dose allowed is between 0.6 to 0.8 mg per liter. Once the water has gone through the filtration process, It is about as clear and clean as it can get. However, there may still be bacteria and viruses remaining. To ensure these are destroyed, there must be a disinfection process employed. The most common disinfection process used is chlorination. Chlorine comes in many different forms including chlorine gas, chlorine dioxide, hypochlorite and others. Water plants monitor the chlorine levels continuously and very carefully in the treated water. Chlorine residual in the water must be 0.4 to 0.6 mg per liter in range. Regulating pH is a major part of water treatment that helps prevent pipeline corrosion and maintains safe drinking water conditions. The suitable pH is between 6.5 to 8.5. So, how does the water come out of your kitchen tap? The stored water is pushed through underground pipelines all over town in what is called a distribution system. The distribution system consists of a large water pumps at the treatment plant, overhead water storage tanks, large pipelines, smaller pipelines, fire hydrants, valve, and water meters in your front yard.